12.6. Students will be able to classify data and analyze samples and surveys. Essential understanding. You can use counting methods to find the number of possible ways to choose objects with and without regard to order. So let's look at tree diagrams. Number 1, make a tree diagram to show all the possible orders for watching 3 movies, a comedy, a drama, and an action film. Well, for the first movie, you have 3 different options. You could pick from any of the 3. Now, based off the first movie, that's going to help you then pick the second movie. Because if I choose a comedy for the first movie, I then can choose a drama or an action movie to watch. If for the first movie I choose a comedy, then a drama, then the third one has to be an action movie. And this is without repeating. So if I chose comedy, action, then it has to be drama. If I chose drama, it has to be action or comedy. And then whatever's left over. Same thing with action. I have drama and comedy. And then, again, whatever's left over. So to put it all together, the number of different orders of movies, you don't need to watch that. Or you don't need to write that down. That's just extra. But anyways, here are all the orders of the movies. CDA, CAD. There's a bunch of different combos. There's technically 1, 2, 3, 4, 5, 6. 6 different combinations. Or 6 different orders, I should say. All right, so let's look at the counting principle. If there are m ways to make a first selection and n ways to make a second selection, there are m times n ways to make 2 selections. For example, let's just say you have 5 shirts to choose from and 8 pairs of shorts to choose from, and you want to know how many different possible combinations there are. Just take the number of items you have times the number of other items you have, and it'll equal 40. That's called the counting principle. So let's use the multiplication counting principle on this one. Number 2, use the diagram below to find out how many ways there are to get from the first floor to the third floor using only escalators. Well, let's just pretend we're a person, okay? And let's think of how many options we have to get to the second floor. Well, there's 1, 2 different escalators. So from the first to the second floor, I've got 2 different ways. Then let's just say I'm this person standing here. Think of how many ways you have to get from the second to the third floor. Well, I've got 1, 2, 3 different ways. I really could have just done 2 times 3 or 6 different ways. Feel free to pause so you can take a second to write this down. If you wanted to see the 6 different ways, it's going up this one, then this one, up this one, then this one, up this one, and then this one, or up this one and here, this one here, and up this one and here. So the counting principle is a great way to show all the different combinations of something. Because what if there were 50 different floors? And then like 6 escalators on each floor. There's a bunch of different stuff. Number 3, feel free to pause and try this one on your own. It says a pizza shop offers 8 vegetable toppings and 6 meat toppings. How many different pizzas can you order with 1 meat topping and 1 vegetable topping? Well, you can use the counting principle here because it doesn't matter what order you choose them in. And we have 8 different selections of vegetable toppings and 6 of meat. So there's 48 different pizza combinations we can make. All right. Now, here's where it can get a little confusing if it already hasn't. We've got permutations versus combinations. Now, most of you have a locker. If you have a lock, it's called a combination. But realistically, it's actually called a permutation because the order in which you enter the numbers matters. Combination, the order does not matter. So, one kind of counting problem is to find the number of possible arrangements of the objects in a set. A permutation is an arrangement of objects in a specific order. So remember, permutation, specific order. Here are the possible arrangements of the letters A, B, and C without repeating any letters. So this is a permutation because once you choose one letter, you cannot choose that same letter again. You cannot repeat letters. So the order does matter here. Keywords for a permutation are typically when you see the words order and arrangement, you know that it's a permutation. Order matters. That's really, really important. Permutation order matters. All right. Finding permutations. Number 4. How many different batting orders can you have with 9 players? Now, this is a permutation because let's just say one person goes. Based on that one person, who you pick next is important because you can no longer choose that first person. So if there are 9 players, let's think of the batting order. So for the first spot, there are 9 different choices. And then for the next one, there's 8 because one person already went. And then 7, and you get it, 6, 5, 4, 3, 2, 1. Now, I can count. Here we go. So this is like the first spot, second spot, third spot, fourth spot, fifth spot, and then here are our options left. Now, this is technically called 9 factorial, where if you're starting at a number and you're counting it down all the way to 1 and you're multiplying, you don't have to do 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 on your calculator. You can actually just do 9 factorial. I believe you press 9, math, and then it's one of those buttons. And that's 362,880 different ways that you could put the 9 players in order. So, again, choices left and batting position. Sorry, I should have shown that at the beginning. All right, I just talked about how this is n factorial. Yeah, the value of 0 factorial is defined to be 1. All right, permutation notation. Now, this is only important if you do not have a TI-84 calculator. So if you have a TI-84 calculator, here's how you do this. All right, if you are given this, here's how you say this. A permutation where there are 5 objects arranged 2 different ways. Now, I'm going to show you, if you have a skinny TI-84 calculator, here's what you do. If you have a skinny TI-84 calculator, you're going to press math, and then I believe it's on probability. There you go. And then if it's a permutation, you go down here. If it's a combination, you go down here. So let's do this. Okay, so you do 5, right arrow, 2. Press enter. Now, if you have a chunky TI-84 calculator, you're going to press 5, math, probability, down to NPR, press enter, and then you would press 2. It's going to look different on mine, but you have to press the left, or you have to select the left number first, then NPR, then the second number. All right, so if you didn't have a calculator, here's what you would do. This number right here, it's going to go at the top. You're going to have 5 factorial, okay? And then you're going to have this number minus this number on the inside of the parentheses factorial. So it's really 5 factorial over 5 factorial. I'm trying to press there we go. 5 factorial over 3 factorial. And if you wanted to continue to do it without a calculator and do it easily, it's then 5 times 4 or 20. But again, if you have a calculator, you can enter this in easily. All right. So, number 5, it says a band has 7 new songs and wants to put 5 of them on a demo CD. Let's just pretend it's a playlist. How many arrangements of 5 songs are possible? Well, this is a permutation because order matters. It doesn't say you're allowed to play the same song multiple times. So, whatever song you pick first, the order matters for the next song. So, this is going to be 7P5 because there are 7 songs. 7 objects. 7 objects or 7 songs, and then we're arranging them in 5 different ways. We're allowed to put 5 songs on that CD. By the way, hint, hint, the larger number goes on the left, smaller number goes on the right. You're going to get an error if you flip it around. So you can literally just enter this in on your calculator and you'll get 2,520. But if you didn't have a calculator, you'd have to put 7 factorial on the top, so right here. And then 7 minus 5 or 2 factorial on the bottom. And then just write it out, cancel out the 2's over 2's, 1's over 1's, and then do 7 times all these numbers. But again, this is not difficult. Just enter this in on your calculator. Let's change number 6 so that this is 3. There are 3 students in a classroom with 8 desks. How many possible seating arrangements are there? Now, this is a permutation. Why? Because whoever you choose to sit in one desk, that's going to influence the choices for the other desks. So, it's a permutation. That's important because you have to pick P or C. So there are 8 total objects, and we're arranging them 3 ways at a time, or 3 students at a time. So again, you can do 8 factorial over 5 factorial if you don't have a calculator, or you can just enter this in on your calculator. Now let's look at combinations. A combination is a selection of objects without regard to order. For example, if you are selecting 2 side dishes from a list of 5, the order in which you choose the side dishes does not matter. All right, so permutation, order matters. Combinations, order does not matter. I would maybe make a Venn diagram like this. This would be something I'd put on a note card. Feel free to pause. All right, combinations. All right, same thing as NPR. This is NCR. So we got combinations, however many objects arranged are at a time. So you can enter this in on your calculator same way as beforehand. So it's 5C2. So calculator, math, probability, NCR, 5, right arrow, 2. Enter. If you have a chunky calculator, you do 5, then math, probability, click NCR, and then click 2. Again, it's going to look different on mine than it does on the chunky calculators. So now it's just a little bit different. Now this time we have the 5 right here. This is what you do without a calculator. So 5 right here. And then for R, you're going to take this 2. It's going to go right here. And then you're going to do 5 minus 2 right there, which is really 3 factorial. So you could have 5 factorial on the top, 5 times 4 times 3 times 2 times 1, and then here's 2 factorial, here's 3 factorial. And again, you can cancel out same numbers on the top as the bottom because it's multiplication. This is if you were to do it by hand with no TI-84 calculator. Number 7, 20 people report for jury duty. How many different 12-person juries can be chosen? Well, again, here's a hint. The bigger number goes on the left, smaller number on the right. So we're going to have 20 and 12, and so this is a combination, all right? If you enter that in your calculator, 125,970. Number 8, in how many different ways can you choose 3 types of flowers for a bouquet from a selection of 15 types of flowers? Okay, so 15 on the left, 3 on the right. It's combination, because the order doesn't matter. 455. Now, I would go ahead and recommend doing the booklet that is below this video so you can get more practice on permutations and combinations just because it's an abstract concept.